So I just wanted to take a moment to discuss the concept of polynomial sequences. So what is a polynomial sequence? A polynomial sequence is a sequence that can be represented using polynomials. So, ax squared plus bx plus c, ax cubed plus bx squared plus cx plus d. So that's really all it is. We can find the equation of a polynomial by just looking at a sequence that corresponds to it. So that's what we're going to do in this video. The first step in finding a polynomial equation from a sequence is to find the degree of the polynomial. So how do we do that? We're going to first find the common difference. So we would do 7 minus 1, that's 6. 19 minus 7, that's 12. 37 minus 19, that's 18. 61 minus 37, that's 24. And 91 minus 61, that's 30. Okay, so there's no common difference there, right? This is what we call our first difference. And I'm just going to write diff, okay? Our first difference, 6, 12, 18, 24, 30. Sometimes there will be a common difference on the first difference, and in that case it would be an arithmetic sequence, but in this case it isn't. So we're going to have to go further. We're going to have to find the second difference. So second difference. How do we find the second difference? Well, we're going to subtract the preceding term from the current term, just like we did with the first differences. So 12 minus 6, that's 6. 18 minus 12, that's 6. 24 minus 18, that's also 6. And 30 minus 24, that's 6. So we have our common difference, but from there, we really want to know what the second difference, what the common difference is. So when you have a common difference at the second difference, that means you have a second degree polynomial, and it's going to be in the form ax squared plus bx plus c. And this is consistent throughout all differences, so if you have a third difference and you have a common difference at that, you're going to have a third degree polynomial that looks something like this. But yeah, so something down here we can read. The difference number at which you find your first common difference corresponds to the degree of the polynomial. Okay, so if you have a polynomial sequence whose first common difference is at the second differences, it will have a degree of 2 and be in the general form of ax squared plus bx plus c, like we were talking about before. So for this right here, we know we can represent it as ax squared plus bx plus c, because it has a common difference at the second difference. But how do we find the a and the b and the c? For that, we can do a few things. The first thing you can do is you can solve a system of equations. So you can create a system of 3 equations and then solve for a, b, and c. So I think that's what we're going to do first. How do we do that? Well, we know when f of 1 is equal to 1, right? We look at this. When we put in 1, we get out 1. So let's put in 1 for this equation right here. So f of 1 is equal to a 1 squared plus b1 plus c. This is just going to be f of 1 is equal to a plus b plus c. Well, we know f of 1 is going to be equal to 1 because when we put in f of 1, we get out 1. So 1 is going to be equal to a plus b plus c. So we have our first equation, but we have to find 2 more. We know when we input 2, we get out 7. So if we put in f of 2 for this general form equation, we'll get 2a, or 4a, plus 2b plus c. F of 2 is equal to 7, right? When we put in a f of 2, we got 7. So 7 is equal to 4a plus 2b plus c. Let's find our third equation. So f of 3 is equal to a 3 squared plus b 3 plus c. 3 squared is equal to 9, so I'm going to do f of 3 is equal to 9a plus 3b plus c. And f of 3 is equal to 19, okay? So 19 is equal to 9a plus 3b plus c. So we have these three equations here, and I'm going to just write them next to each other so we can see them better. From here we can solve this, right? We can solve for all variables. That will take a little bit of time, and there's actually an easier method. We can reduce this to a system of two equations by finding one of these variables. Which variable are we going to find? We're going to find a, because there's actually a formula to find a, and we'll look at that up here. So the leading coefficient of a polynomial, which is a, right, can be found by dividing its first common difference by its degree factorial. So we could say a is equal to the common difference divided by the degree factorial. What's our common difference? Our common difference is 6, right? We already know that. So if we were to say a is equal to 6 divided by our degree factorial. So our degree is 2 factorial. So if you're not familiar with the concept of factorials, it's the product of a descending terms, essentially. So if you had like 6, 6 factorial, this would be equal to 6 times 5 times 4 times 3 times 2 times 1. Okay? So a is equal to 6 over 2 factorial. 2 factorial is going to be 2 times 1, and that's just 2, alright? 6 over 2, that's 3, we know that. A is equal to 3. So if we just wanted to rewrite this, it could be 1 is equal to 3 plus b plus c. 7 is equal to 4 times a, 4 times 3, which is 12, plus 2b plus c. Okay. Let's get these numbers on just one side here. So this would be minus 5 is equal to 2b plus c. And this would be equal to minus 2 is equal to b plus c. Alright. What can we do from here? Well, we can cancel out one variable. We can cancel out c, but to do that, we're gonna have to flip the signs, okay? So if we flip the signs, we'd get 2 is equal to minus b minus c. And let's just write this other equation up above. Okay, so let's add these together. Minus 5 plus 2, that's minus 3. 2b minus b, that's b. C minus c, that's nothing, alright? So b is equal to minus 3. We have one more. So let's just keep this written down here. A is equal to 3, and b is equal to minus 3. Now, lastly, we have to find c. This is pretty easy because we can just take this. 1 is equal to 3 plus b plus c. 1 is equal to 3 minus 3, right, because this is our b here, plus c. Okay, 3 minus 3, that's just 0, plus c is equal to 1. So it's pretty obvious that our c is equal to 1. So we have all of our variables. Now we have to actually plug those into the a plus b plus c in the quadratic equation. So f of x is equal to 3x squared plus minus 3x plus 1. So this would actually be, this right here would be the equation that corresponds to the sequence. Now if you don't trust me, we can try plugging in a number. So let's just try plugging in 3, and if we plug in 3, we should get out 19. Okay, so f of 3 is equal to 3 squared minus 3 plus 1. This is 9 times 3, that's 27. 27 minus 9 plus 1. This is going to be 18 plus 1, which of course is 19. And that corresponds to what we have over here, right? We plugged in 3 and we got out 19. So this is just a little video to discuss the concept of polynomial sequences and how you can find a polynomial equation using a polynomial sequence.